Hello friends, let's learn torque on a dipole in an uniform electric field. Here the word is uniform electric field. This means that the electric field lines are equidistances. So we have drawn here an electric field line which are equidistant. This is said to be uniform electric field line. This is said to be uniform electric field line. They are equidistant and parallel to each other. This field line is going from this side to this side. So this means that here must be plus charge and here must be minus charge, because electric field line originates from plus charge and it moves to minus charge. So let the electric field is E here. E is the electric field. Let us place a dipole minus q plus q of length 2a. 2a is the length of dipole. Then this minus charge will attracted towards this plus charge. So here a force F1 is equals to minus q into E will play on this charge. Here E stands for electric field and Q stands for discharge, and minus is because force and electric fields are in opposite direction. Electric field is in this direction and force in opposite this direction. So these are anti-parallel. And here the force F2 is Q into E. Here it is positive because force and electric field are on the same direction. Let the angle is theta between this P dipole moment and electric field. Let us draw a perpendicular from this point and extend this point. This is joined at 90-degree angle. And here also it is 90-degree angle. A, this is B, and let this point is M. Since this angle is theta, so this angle is also theta. Now in right triangle BAM, you observe that sine theta is equals to perpendicular by hypotenuse. So perpendicular is BM and hypotenuse is AB. So this is equals to BM and AB is equals to 2A, right here 2A. Multiply 2A this side, you have BM is equals to 2A sine theta. So here we have find the distance B to M. So I am writing a distance. This is 2A sine theta is the distance from B to M. Now we will work for force at point A and B. So force at point A is, this is F1 force, which is equals to minus Q into E. Force at point B is F2 force, which is equals to plus Q into E. So total force, which can be said to be rectilinear force. So total force or net force is F total is equals to F1 plus F2. F1 is minus QE and F2 is plus QE, which sum up to be 0. This means that the sum of two forces is 0. So there is equal and opposite force, and this equal and opposite force are acting at two different points which are collinear. So they create a couple of force. When couple of force will be created, then a torque is generated and the dipole will rotate. So let us work for torque. Torque is equals to magnitude of either force into perpendicular distance between forces. So you have tau symbol equals to QE and perpendicular distance is BM. The value of BM is written 2A sine theta. So QE 2A sine theta is here. Q into 2A is P. So PE sine theta. This means that torque tau equals to P cross E in vector form. So torque tau equals to P cross E. Now let us have a numerical based on this. So first you see some numerical based on this, then I will explain the cases for torque. So let us have a numerical number 1. Numerical number 1. In this numerical, I am taking a electric field E. The value of electric field is 10 to the power 4 Newton per Coulomb. Let us take a dipole moment P and at an angle of theta equals to 30 degree. Let the length of dipole moment, here is minus q charge, here is plus q charge, so the length is 3 millimeter. So torque will acting in this direction, because when you put your right hand, you have the formula torque tau equals to P cross E. So when you put P and you turn your fingers towards E, then according to right hand thumb rule, the thumb is inward. So the torque will be inside the plane of paper, and it is according to right hand screw rule or Maxwell screw rule, it will move inside the plane of paper. So this line means that it is inside the plane of paper. Let the torque is 9 into 10 to the power 26 Newton per meter. You have to find P, and you also have to find what is the magnitude of charge. Okay, in this question, then you know this is the formula. So this means that torque tau equals to P E sin theta. What is torque tau? Tau is 9 into 10 to the power 26. P you don't know, but E you know, it is 10 to the power 4. And you know what is angle theta. So it is have sine 30 degree. You know sine 30 degree is half. So it is P into 10 to the power 4 into half. It is 9 into 10 to the power 26 this side. So you have the formula. This is equals to P is equals to 9 into 2 18, and here 26 minus 4. So you have 10 to the power 10 to the power plus 22, and unit of P is coulomb meter. So you get what is P here. Now next part you have to find magnitude of charge. So you have find part A, part B. You know P equals to Q into 2A. So P is 18 into 10 to the power 22, and here you have Q. What is Q? You don't know Q, but you know what is 2A. 2A is 3 mm. It is 3 10 to the power minus 3. So 3 will cancel out. You have 6. So Q is equal to 6 into 10 to the power 25 coulomb. Thus, here in this question, you know what is the value of torque and what is the value of charge. Let us have a question numerical from your NCERT book. NCERT numerical. Let us have question number 2. NCERT question. In this question, NCERT book, the book have given that electric field is 5 into 10 to the power 4 Newton per Coulomb, and dipole moment P is also given, which is 4 into 10 to the power minus 9 Coulomb meter, and you have to find, angle is 30 degree, you have to find torque. What is torque? Very simple question. Here torque tau is equals to P E sin theta formula. So it is P, what is P? Put the value of P. Value of P is 4 10 to the power minus 9. Value of E is 5 10 to the power 4 and sine 30 degree, which is half. So 4 into 5 20, and 10 to the power you have minus 9 plus 4, so 10 to the power minus 5, cancel this, you have 10 here, so you have 10 to the power minus 4 Newton per, here it is Newton meter, unit is Newton meter, or the unit can be joule also. So value of torque is 10 to the power minus 4 Newton meter or joule. Let us have some case that what will be happen on the torque when dipole is placed perpendicular, when dipole is placed in anti-parallel, then what will be happen. So you have case number 1. This is electric field E. Let the dipole is placed here perpendicular. This means that this is a dipole moment P. So here you have minus q charge, here you have plus q charge. So a force will be act on this, because this is plus here and this is minus here. So this create electric field. So this plus will attract this. So you have a force here F1, which is equals to Q into E with a minus sign. Here is also a force F2, which is equals to Q into E with a plus sign. So net force F net equals to F1 plus F2, which is equals to QE minus QE, which is minus QE plus Q, which is equals to 0. So the force is again 0. And since the angle theta is equals to 90 degree, so here part number B, torque equals to P is sine 90 degree. Sine 90 is 1. So it is equals to P. This means that torque max. Maximum torque will be created when the dipole is placed perpendicular to the electric field. Now what will happen when the dipole is placed parallel to the electric field? This means that this is the electric field E, this is the dipole moment P parallel. So minus Q here plus Q here. In this situation angle theta is equal to 0 degree. So angle theta is equals to 0 degree. And force acting on this charge is this side. This is F1 is equals to minus QE. Here the force F2 equals to plus QE. So F net force is equals to minus QE plus QE, which is equals to 0. And number B part, torque equals to PE sine 0 degree, and sine 0 is 0. So you have P into 0 is equal to 0. Thus the net force and torque is 0 when the dipole is placed parallel to the electric field. Now what will happen when the dipole is placed anti-parallel? Third case. So here electric field is placed like this. This is electric field anti-parallel here. So if we anti-parallel, or don't take shortcut, draw a same diagram. This is electric field E. Here I am placing the dipole. So this is anti-parallel. So if this will be anti-parallel, this means that plus Q charge is here and minus Q charge is here. So the force acting on this charge is F2. This is plus and this is minus. This plus and minus produces electric field. So these two plus charge will repel each other. This means that force F1 is equals to Q into E, and the direction of QE along this direction. In the same way, here another force will creating on this. This is minus charge is here, so it will repel each other. So F2 force is equals to QE, and this is in this direction. Now see, this is the direction of electric field, so it will be positive. This is the direction of opposite of electric field, so this is negative. Okay. Now in this situation also, you have the first force QE and the second force is minus Q. So again the net force is 0. Now what will be the torque? The angle theta is equals to 180 degree. So put here 180 degree. You know that sine 180 degree is also 0. So the torque is 0 here. So in this situation, if the dipole is placed either parallel or anti-parallel, in both the situation, the net force and the torque is 0. But when the dipole is placed perpendicular to the electric field, then net force is 0, but the torque is maximum. Thus, you learn what will be the value of torque when placed in uniform electric field. So do like, share and subscribe my channel.